I'm excited to be here. Let's start. I'm going to talk about building a telemetry at Starburst and how we use actually Starburst Galaxy to enhance our data lives. First, let's talk a little bit about me. Since this is about me, I'm from Seattle, Washington. I'm a staff data engineer at Starburst, and I've pretty much worked with data my whole career. I think we all can make that argument. A couple facts. I have one cat, and I have many cactuses, and I'm convinced that cats and cactuses are the cat of houseplants. I've also had 13 broken bones. I'll let you guess how I got those bones broken. Today I'm going to be covering data engineering at Starburst. I'm going to be using telemetry data, and I'm going to be talking about how we actually use Galaxy and dog food our products. Data engineering. What is a data engineer in the first place? There's a lot of conversations about what data engineer is. We mostly do data pipelines, we create analytic layers, we provide business data to consumers, but we tend to do a lot more. We also tend to do a lot of the initial discoveries. We also maintain, and I would actually argue we actually create as well. We often maintain legacy products and systems and tools. We build custom tooling with Python, mostly Python. And a lot of times we do quality testing and maybe documentation. I always tell everybody I'm going to be doing documentation and I rarely get to it. So I'm sorry in advance. We also try to translate ideas into understanding from data. I think that is pretty important. Just so everybody is clear, we are literally trying to make data meaningful to consumers. I'm going to pause for a moment for that. So at Starburst, the data engineering program is actually new. And so we had to start from scratch. The product is great for data engineering, but we had to build up our own data engineering environment. We started, of course, with Galaxy. We want Galaxy to be the forefront of all of our data engineering experiences. We use dbt. I'm a huge dbt fan. We use it to manage our models. We're also using Git. I'm sure nobody can survive without any type of source control. And I've worked at a couple companies that had zero source control, and I was shocked by it. We also default to Iceberg and Parquet. Fahad did a great talk. I know in the background of a lot of his work is Parquet and Iceberg. I love Iceberg and Parquet, so I'm not going to go into too much detail about it. And our default language, as I mentioned before, is actually Python. Here's a really quick example of what our dbt projects look like. We have models. We have the model definitions. We have packages. I recommend the Starburst data Trino utilities if you want to use dbt with Galaxy. We define our profiles to understand schemas and credentials and clusters that we were using. And we also build our own macros. I have this special little macro up at the top called timestamp for Iceberg. It's very, very popular. I actually wanted to show this, and you'll thank me later for this. You'll probably want a picture of this, but this macro is going to save you a lot of heartache on Iceberg tables. You will thank me later. Here's a really quick overview of a normal data architecture. This is a marketing material at Starburst. As you can see, Starburst spans the whole universe of our products. We have 3 different discrete buckets of information. We have the land. A lot of people call that the bronze stage. We have a structure, silver, the silver stage if we're using the medallion data flow. And we also have a consume, or the gold stage. We use Starburst as the entrance to all of our data. We process data in each of these different stages, and then we serve to a BI layer or to analytics layer. And of course, dbt is used to manage the interior parts of these layers. Excuse me. Data architecture. So, and this is purely preference. I'm not sold to, I don't need to advocate for this particular structure, but I love doing my data architecture as similar to the medallion architecture. I love to land it, but we call it source internally. I should probably be renaming everything to land. We do structure. All of our structured data, all our transformations or aggregations are in stage. And consume, we call them curations. You can have, a couple slides ago, we saw the same structure in the dbt project. And we actually organize our Galaxy catalogs in the same manner. So a catalog will have these same schema definitions. We work mostly with the DBT models. We just generically call them models. They're the artifacts of what we're building and we're creating on our data lake. We also use, since we're using DBT for the most part, we also make sure we prepend our model names to be descriptive, except for Curations. So we'll use source or stage as a prepend on our model names. And in Curations, we actually want to have something that is more definite and more clear about what a curation means, because it has to serve some type of data purpose. One of the things that I love about DBT is that we can actually do the testing within DBT. Below is a really great DBT utility that was just released recently, where we can do cardinality checks against multiple fields. Saves my life all the time. We tend to group all of our models along DBT projects. We tend to call those topics, and the topic usually represents the set of models that are from a specific source of data. For example, one of our topics would be telemetry. Another topic might be CRM. Another one might be lever or some other source of information that we're getting all of our information from. I have a real quick walkthrough with telemetry data. Telemetry data. In this case, a lot of our telemetry data is actually landed by an external source. So what we're really doing is we're managing data that has already been provided to us. This is very nice for me. That's less work and less responsibilities on my end. The data tells us who's using what and how much. We have our telemetry data as ND JSON, new line delimited JSON, which means one row of data per line. The JSON's incredibly flat. This is a huge boon for my work. And one row of data actually represents a single event. Here's an example of telemetry. All this is private information, so look away at the node ID. We have a timestamp. I'm assuming everything's UTC. In my world, everything should be UTC. I'm sure in many of your world as well. We have a node ID. We have node version, because everybody wants to know node versions. And we also have some type of consumption value. We can assume that this is some form of, in this case, it is a cumulative score of consumption. So we have this data. The telemetry data is landing on our data lake. We want to create a source table for this data. With JSON and with Galaxy, we're able to just create a source table of information with a table create function just like this. Oh, can I get water? Sorry. We have our events, our nodes, and our timestamps. And of course, I'm using a Hive table for this. So my timestamp is timestamp 3. And then I have my external location is my data lake is obviously S3. And I also partition my data by date, because I'm going to assume there's lots and lots of details. I can actually create more evolved partitions for data, but in this example, I'm just going to assume I can manage it with just in a date partition. So I have this Hive data. It's sit there ready to have some analytics and some transformations being processed into it. So I need to have a stage table. Since we use Iceberg, one of the first things we want to do is we actually want to move the Hive data off of Hive, and we actually want to transfer it into Iceberg. So we're going to create the landing table. And if you're unaware, we actually manage all of this through DBT. So this is just the SQL I'm using to explain what's going on. The create table here, same. The timestamp, we actually cast it as a 6 in this instance. We have a consumption value, we double it, it's a double. And then of course you see the table formats below. So I'll give it a quick pause. So now that we have Hive data on the left hand and we have Iceberg where we want it to be on the right hand, our SQL becomes very simple. It's literally insert, select from, and do stuff. As you can see at the bottom, that's where we would have introduced that macro that I pointed to you earlier when we're creating this as a DBT table. But this is a super simplistic insert statement, and it works like a charm. We can make it more complicated or less complicated, like if we wanted to materialize the data or we wanted to partition, like create better indices for the data. You'd be able to do much more. So what have we seen so far? We're able to do Hive. We're able to connect to Iceberg. We're able to create staging tables easily, and we're using insert to basically convert our tables to Parquet files. That JSON is now a Parquet file. We now have metadata. We have all these great attributes that come built into the JSON and Iceberg, or the Parquet and the Iceberg tables. And so we use Galaxy. I was kind of a fan of Galaxy before I started my work there. I'm more of a fan now. I could go on and on and on, but I just picked 3 features I really wanted to talk about how I actually use these features in my everyday life. The first feature is data quality. I use data lineage and I use data products. We saw Fahad did a really great example of data products. I'm actually really curious about how he did that more. I need to know more about that. Data quality it was released this year. It allows us to build data quality built right in at Starburst against tables. We are able to build better data quality by creating tests and checking those tests. One of the most important factors about data quality is I always get pushback on all the data and pipelines I create, which is how trustworthy is your data actually? Or why are my numbers different? I always have to justify my data and my logic and my assumptions about data. And I think data quality helps bridge that understanding and creates trust between me and analysts. They should be challenging my data. This should be a normal part of our cycle. It's not personal, it's just verifying that this information is correct. One of the other great things about data quality feature is we're able to create alerts. So on Slack, in the morning, I'll get alerts if there's a problem with the data quality. I go check out the table, I resolve it with my team, I resolve it with the analysts if they're seeing it first. Hopefully they're not seeing it first. Hopefully I'm seeing it first and then fixing it ahead of time. I just think this feature is amazing. One of the really great aspects of this feature is I can actually have a historical context of this data quality over time. I think, wow, I keep trying to build that. Data lineage. I'm not sure if anybody's familiar with the data lineage feature on Starburst Galaxy, but it does exist in dbt. dbt allows you, if you're using references and you're using the macros in an efficient manner, you're able to build up your own lineage charts on dbt. Of course, you have to serve it as a web service somewhere else that is not Galaxy. The nice thing about data lineage with Galaxy is that it becomes a one-stop shopping for information about the actual models that we're building. We're able to look at all these models, all their dependencies, all the fields that might come from these very extravagant or exotic sources, and we can have conversations with other people about this as we dive into the data lineage. My favorite aspect about this data lineage is it's tied one-to-one with the actual deployed models, so there's no divergence between the model that I have deployed, the model that's in my source code, and the model that might be represented on some other website somewhere else. And of course, data products. I love data products. In the previous, a couple slides back, I was talking about topics. Sometimes we want to have a CRM conversation with telemetry, so we want to understand counts, and we want to understand telemetry data at the same time. We have been using the idea of promoting curations that would handle these cross-topic conversations as data products. Data products are amazing. They create context, information, links, people to reach out to if there's a problem, detailed information about the fields and the tables. Of course, we have to fill all that in, but I think it's incredibly powerful. And then it also provides us the ability to have a place that is clear to discover on Galaxy that will answer complex questions. I've been building on Galaxy for the last year and a couple months now. I think the most important thing, and one of the things I've always struggled with in the past, is we always had different systems that were different parts of the truth, but none of them were the full truth, and a lot of those truths diverged from the original source of information. Galaxy provides us a single source of truth for what the models are, what the fields are, what they mean, what the lineage is, and if it's good or bad data. Iceberg is there's a lot of buzz about Iceberg right now, and it's well deserved. It's incredibly feature rich. It performs very well on the data lake. We love to use data lineage to have conversations with people. It's really great. Another really great aspect of Galaxy is we have really easy cluster management. I also can't stress this enough. I think one of the best things that we offer is that the metadata and the data is really mine. Like our tool is on top of your information. You don't have to subscribe to our tool just to get the metadata and data back. But of course, it's greatly leveraged by using our products. And also, who doesn't want quality data? I think we're all after quality data. Thank you very much.